Similar to how multiplication is a shorthand of repeated addition and exponents is a shorthand for lots of multiplication, factorial is also a shorthand for multiplication. The factorial of a positive integer or a variable that represents a positive integer is represented by writing an exclamation mark after the positive integer or after that variable. And what this means is that we multiply the positive integer by every positive integer smaller than it. So here 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 20 factorial would be equal to 20 times 19 times 18 times 17 times 16 times 15 all the way to times 5 times 4 times 3 times 2 times 1. Or we could have also written 20 factorial in terms of 20 times 19 factorial. Or we could write this as equal to 20 times 19 times 18 times 17 factorial. So in general, n factorial is equal to n times n minus 1, n minus 2, n minus 3, all the way to 3, 2, and 1. So that's factorial in general. And the reason we have factorial notation is because it's very common in combinatorics. So to save space and time, we write an exclamation mark as opposed to a bunch of variables. So let's try some exercises with factorial. Let's start with this one. Simplify. Simplify 8 factorial divided by 6 factorial. So here, factorial is kind of like a function, so we can't just cross out the factorial. That would be wrong. So instead we go back to the original definition of a factorial. 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divide by, 6 times 5 times 4 times 3 times 2 times 1. Everything crosses out. Is equal to 8 times 7 is equal to 56. So 8 factorial divided by 6 factorial is equal to 56. Let's try another example. 10 factorial minus 6 factorial. Divide by 10 times 9 times 7. 10 times 9 times 8 times 7 minus 1. And so we look at this and we say, wow, the denominator looks pretty weird. The numerator also looks kind of weird. So what we can do is factor the numerator into 6 factorial times 10 times 9 times 7, times 8, times 7 minus 1 over 10 times 9 times 8 times 7 minus 1. And the numerator makes sense because 6 factorial times this section is equivalent to 10 factorial. So common terms cancel out. This is simply equal to 6 factorial, which I believe is equal to 720. Let's try another example. Simplify 10 minus 5 factorial. So this is basically just a word of caution. This does not equal to 10 factorial minus 5 factorial. No, it does not equal. Instead, we do BEDMAS, order of operations. This is equal to 5 factorial. And just for common interest, 1 factorial equals 1. 0 factorial maybe equals 0, but no, it equals 1. This will make a bit more sense once you start learning about Poisson distribution, whether the denominator will be 0 factorial. And, it can't be 0 because something divided by 0 would be undefined. Let's try one more example. 15 factorial, to simplify this, divide by 13 factorial times 13. So we realize the 13s can cross out. So 13 factorial becomes 12 factorial. Well, 15 factorial divided by 12 factorial is equal to 15 times 14 times 13. So this would be our answer. And okay, we're running out of space. Here, let's use this side over here. Suppose we know that 9 factorial is equals to 362,888. Then what is 10 factorial. Yes, interesting. We have two punctuation marks here. So 10 factorial, we notice, is equal to 10 times 9 factorial. Hence, it's equal to 10 times 362,880. So 10 factorial is equal to 3,628,800. So this would be our answer for 10 factorial. So right now you might be wondering, does the factorial of a negative integer exist? So can we say that negative 5, factorial is equal to negative 5 times negative 4 times negative 3 all the way to negative 1? Right now I can't think of a time when we would use this, but let's suppose that the factorial of a negative integer exists. Then another way of writing this would be to write it in terms of a positive integer. So positive factorial, 5 factorial times all these negative 1s. How many negative 1s are there? There are 5 negative 1s. So negative 1 to the power of 5. And so if negative factorials exist, then that means negative n factorial would be equal to n factorial times negative 1 to the power of n. So throughout this video, I hope you have learned a better understanding of factorials, what they are, how they work, understood some of the exercises, and also perhaps learned to be able to translate a negative factorial in terms of a positive factorial. So I hope you have learned something and look forward to seeing you in my next tutorials.